Okay, now we're doing question 9 on section 2.4. And the first thing we have to do is graph this piecewise function and then answer 4 questions. So to graph each piece, we'll examine the endpoints. And so if x is 0, this is the domain of this piece of the function. If x is 0, then we'll have the square root of 1, and the square root of 1 is 1, so here we are at 0, 1. If x is 1, now notice 1 is not in the domain of this, but we can still allow x to be 1 to find where our bound is, where that point is, and at that point we'll put an open circle to designate that x can't be 1. 1 is not in the domain. So if x is 1, we're going to get a 0. And so here we are at 1, 0. And rather than put a solid dot, we'll put an open circle, designating the fact that 1 is not in the domain of this function. And it's going to be a curve, and it looks like that. Okay, now, 1 is in the domain of this piece. And when x is 1, f of 1 is 1. So here we are at 1, 1. Now, we'll let x be 2, and again, 2 is not in the domain of this function, but it allows us to locate the endpoint of this piece of the function. And so here we are. If we let x be 2, we'll be at, we'll designate that fact that 2 is not in the domain of this with an open circle. And this point right here is 2, 1. And now we'll let x be 2, and if x is 2, then we get the point 2, 2. Okay, now it's time to answer the questions. And the first question is find the domain and range of the function. Well, if you notice, we're going from 0 to everything but 1. Now we pick up 1 right here, and we're going from 1 to 2, everything but 2, but we pick up 2 here, so the domain equals the set x such that 0 is less than or equal to x, which is less than or equal to 2. Okay, now let's do the range, and the range equals the set y such that, and we're bounded by 0 but not including 0, so 0 is less than y, which is less than or equal to, we do get to 1, equal to 1, and we also have y can equal 2. And so there's the range of the function. Now b, it says what points c, if any, does the limit as x goes to c of f of x exist? Well, will you agree that the limit, for a limit to exist, at x has to be on an open interval? And so any of the points between 0 and 1, the limit will exist, and also between 1 and 2, not including 2 or not including 1. So we'll designate those with open intervals. So we're going from 0 to 1, open intervals, union with an x 1 to 2, and again open intervals. Now c, it says at what points does only the left-hand limit exist? Well, the left-hand limit are all the points to the left of whatever this limit might be as we approach from below. And a key word here is only. And the left-hand limit only exists for the value x equals, and that's going to be 2. And I'll check this out. X equals 2. There's a left-hand limit for 1. X equals 1. There's a left-hand limit for x equal 2, and the key word is, at what point does only the left-hand limit? There's a right-hand limit also at x equals 1, but there's only a left-hand limit. There's no right-hand limit as x equals 2. So x equals 2 is our guy. D. See, that key word is only. Now let's do D. At what point does only the right-hand limit exist? Well, let's see. There's a right-hand limit because we're looking at a value as x approaches this value from above. There's a right-hand limit at 0. There's also a right-hand limit at 1. But there's also a left-hand limit at 1. So they're talking about only. So we just have to go with at 0 we only have a right-hand limit. So that's going to be x equals 0, where at 1 we not only have a right-hand limit, we also have a left-hand limit. So, okay, now we're doing question 11, and we've got to find the left-hand limit, because x is coming from the left, of the square root of the quotient of x plus 2 over x plus 1. As x goes to negative 0.5. So we can just simply evaluate directly because this function is defined for all reals. Well, it's defined for all reals less than or equal to negative 2 and greater than 1. So negative, or greater than negative 1, I beg your pardon. So negative 0.5 is in the domain. So this equals the limit as x goes to, well, as I said, we can simply evaluate directly, so we don't need the limit symbol anymore. We'll just look at the square root of, and this is negative 0.5 plus 2 over negative 0.5 plus 1, which equals, and this is going to be 1.5. 2 minus 0.5 is 1.5, which is 3/2. And 1 minus 0.5, or 1/2, is going to be 1/2. And now when we invert and multiply, we get the square root of 3 over 2 times 2 over 1, and the 2's divide out, and we just get the square root of 3. And that's what the limit exists.